Remember, L'Hopital's rule can be applied if and only if direct substitution gives you 0 over 0. And what is L'Hopital's rule? Calculus is a branch of mathematics that studies the relationship between changes in quantities. It is from the Latin word small stone. And the major areas of calculus are limit, differentiation, and integration. Of course, applications being the applications of differentiation and applications of integration. What is limit? Sometimes we can't figure out something. We try to imagine what it will be as we move closer and closer, as we approach. Okay? Meanwhile, differentiation is a branch of calculus that studies the rate of change, how a quantity change with another. It studies gradient, dy over ds, slope, change in y over change in s. How does this change with respect to that? For example, how does velocity change with respect to time? All these are covered under differentiation. Since calculus is from the Latin word small stone, breaking the stone down, cutting the stone. Integration is anti-differentiation. It is the converse, the reverse of differentiation. So it is to build up, to join. Today, we shall be treating the limit of a function. Sometimes, we can't figure out some things, or we can't get to the end of certain things. But we just try to predict what will happen as we move closer. For example, if y is equals 1 over s, let s be equals 10. Y will simply be equal to 1 over 10. That is 0.1. How about we increase s to 100? If s is equals 100, y is equals 1 over 100. That is 0.01. How about we say let s be equals 10,000? If s is equals 10,000, y is equals 1 over 10,000. This is equals 0.0001. How about we say let s be 100,000, or let's say 1 million. If s is equals 1 million, y is simply 1 over 1 million. And that is equals. Now, as we proceed, it continues to go down. What does it mean? This implies that as s tends towards infinity, y simply tends towards 0, or y becomes 0, because this is already going towards 0. This is the concept of limit, and it is very important in calculus. So, limit of a function. Now, given this, we can read it as the limit of function of s as s tends to a is equals L. The limit of function of s as s tends towards a is equals L. This is how this question or this is read. So here it says find the limit as t approaches 10 in the expression p is equals 3t plus 7. Before we do that, take note of something. T approaches 10 is written this way. It is different from t is equals 10. So approaches mean it's moving towards, it doesn't. Just like we explained in infinity earlier. So if we are looking for limit and we say it tends to a particular value and not that value, that implies that to solve any question under limits, we need to simplify to the lowest form before we substitute. So given p is equals 3t plus 7, no, it doesn't need simplification, because there's something we can do here to simplify this equation or to simplify this expression. This is expression because there is no equality sign. And everything is equation because there is equality sign. Hope you understand that. If yes, we simply say that as t tends to 10, p is simply equals 3, 10 plus 7. This is equals 30 plus 7 equals 37. That is the answer. And look at the second one. It says the limit of s squared minus 4 over s minus 2 as s tends towards 2. Limit s squared minus 4 as s tends towards 2. If you have something like this and you are asked to look for the limit as s tends towards 2, the first thing that comes to mind is let's substitute like we did earlier. So s is 2, so we have 2 raised to the power of 2 minus 4 over s is 2, 2 minus 2. This will give you 4 minus 4 over 2 minus 2. This is 0 over 0, and that is undefined. You see? So this is why I told you earlier that limit is different from equality. So what s tends to 2 doesn't mean that s is equals to no. So at the lowest form, after simplifying, that is when you substitute the value of s to be 2. In this case, we simplify this expression. How do we simplify? Is from the normal mathematical skill or normal mathematics skill. Given s squared minus 4, 4 is the same thing as 2 squared. We say s squared minus 2 squared over s minus 2. Now s squared minus 2 squared is the same thing as s minus 2 and s plus 2. Because if you have a minus a squared minus 2 squared or a squared minus b squared is simply a minus b, a plus b. If you don't know this rule, simply know it now. We can further prove that s times s is s squared. S times plus 2 is plus 2s. Minus 2 times s is minus 2s. And minus 2 times plus 2 is minus 4. So this is s squared minus 2 plus minus 2 minus 2s. This is 0. You have 2 and you are owing 2. You pay, the debt disappears. So minus 4. So you see, this is the same thing as this. We simply say that the limit as s tends to 2 of s minus 2 s plus 2 over s minus 2. From here, s minus 2 can simply cancel s minus 2, giving you the limit of s plus 2 as s tends to 2. It doesn't need simplification anymore. If it needed to be simplified, we simplify to the lowest form before substituting. In this case, we can simply substitute s to be 2. So it is simply 2 plus 2. S is 2 plus 2. This is equals 4. So that is the answer. So the limit of s squared minus 4 over s minus 2 as s tends towards 2 is equals 4. Remember, you simplify, then you substitute. This is question number 3. The limit of s squared plus s minus 2 over s squared minus 1 as s tends towards 1. So as s approaches 1, what does this give you? What is the limit of this function? Remember, the limit of a function. If we substitute s to be 1 directly, you simply have 1 squared plus 1 minus 2 over 1 squared minus 1. Substitute means anywhere you see s here, put 1. That is substitution, to replace. This will give you 1 squared is 1, 1 plus 1 2, 2 minus 2, that is 0, over 1 squared is 1 minus 1, that is 0. So this is undefined. If it is an objective question, you just see A 0 and B other values. You simply shade 0 and you are happy. Yes, I finished work. I finished work. No, no, no. That's the wrong thing. This is why a lot of persons fail objective examinations. We need to simplify to the lowest form before substituting. I'll be saying it and I will say it again. S tends to 1 doesn't mean S is equals 1. There's a big difference. It's approaching. It doesn't get to. So for us to get that value as it approaches, we simply break this down to the lowest form before substituting. Looking at this, this is simply a quadratic expression. S squared plus S minus 1. So we can simply factorize. I have a video on quadratic equation on factorization. I will explain the step. If you don't understand, I will share a link to that video. Now, given S squared plus S minus 2, this is the same thing as S squared plus 1S minus 2. This is AS squared plus BS plus C. This is the standard form of any quadratic equation. So where A here is 1, B is 1, and C is equals minus 2. We look for a number that when we add, we get 1 plus 1, and when we multiply, we get minus 2. So the two numbers that when we add, we get 1 plus 1, and when we multiply, we get minus 2, they are simply minus 1 and plus 2, or simply minus 1 and 2. So these are the two numbers, minus 1 and plus 2. We simply replace here with them to have S squared minus 1S or minus S plus 2S minus 2. So this is simply the numbers that when we add, we get 1S. It is here. So 1S, we factorize by grouping them. We group here and here, and here and here. What is common between these two? Between S squared and S is common. So we simply pick 1S, the remaining S minus 1. S squared divided by S is S, minus S divided by S is minus 1. So here, plus 2S minus 2. 2 is common between them. So we simply take plus 2. 2S divided by 2. 2 cancels 2, remaining S. S minus 2 divided by plus 2 is minus 1. This is quadratic equation. If you already have a sound knowledge of quadratic equation, then this step is not a problem at all. So we simply look at this, we pick this one, and we pick this one. We take S minus 1, and we take, but this and this are common. We pick one, then we pick this other one. We factorize this expression. Now for this one, remember what we did in the question earlier. We said that S squared minus 1 can also be written as S squared minus 1 squared. We've not changed anything. 1 squared is the same thing as S squared. Sorry, 1 squared is 1. We didn't change anything. And we also said that S squared minus 1 squared, which is A squared minus B squared, is the same thing as A minus B and A plus B. You can take the video back to how we are able to break this down. Okay? So this is the same thing as S minus 1, S plus 1. We've broken down the numerator and the denominator. The function becomes the limit of S minus 1, S plus 2, all over S minus 1, S plus 1, as S tends to 1. So we've simplified now. Okay, look at the numerator and denominator. This and this are similar, and it's multiplication holding them. We can simply cancel this. This will give us the limit of S plus 2 over S plus 1, as S tends to 1. this case, let's substitute. If s tends to 1, this will give you 1 plus 2 over 1 plus 1. This is 3 over 2. So this is 3 over 2. The limit of s squared plus s minus 2 all over s squared minus 1 as s tends to 1 is equals 3 over 2. Instead of applying or using the long method we used in solving the question earlier, question number 3, we can simply apply L'Hopital's rule. L'Hopital's rule simply states that when you are given a function like this, having s, you can simply differentiate the top and differentiate the bottom separately. After that, you substitute the value. Your answer will be very, very easy. That is L'Hopital's rule. The differentiation is not the standard differentiation. Like you don't apply product rule or quotient rule. You simply differentiate the numerator, keep your answer. You differentiate the denominator, keep your answer. That is L'Hopital's rule. So in this case, the limit as s tends to 1 of s squared plus s minus 2 over s squared minus 1 is simply, when you differentiate this, if s squared plus s minus 2 divide the s, or differentiating this, we simply have 2s plus 1. When you differentiate s squared, you have 2s. And when you differentiate s, you have 1. Differentiate minus 2, constant, you get 0. And when you differentiate this, you have 2s. S squared is 2s, and when you differentiate minus 1, you have 0. If you don't understand what I'm saying, don't worry. I have a video on differentiation, integration, applications of differentiation, applications of integration. So they are all simplified. So I will share a link to those videos. Okay? So don't worry. So given this is the numerator, this is the denominator. So we simply say the limit of 2s plus 1 all over 2s as s tends to 1. This is substituting. We have 2, 1 plus 1 over 2, 1. This is 2 plus 1 over 2. That is 3 over 2. So you see, L'Hopital's rule is very, very easy. Alright, look at this last question. It says, find the limit of s cos s minus sin s all over s raised to the power of 3 as s tends to 0. Now, as s tends to 0, let's try direct substitution. In direct substitution, we simply have putting s as 0. We have 0 cos 0 minus sin 0 over 0 raised to the power of 3. Cos 0 is 1. 0 times cos 0, that is 0 times 1. That will give you 0 minus sin 0 is 0. 0 raised to the power of 3 is 0. So this is equals 0 over 0. Therefore, direct substitution gave us 0 over 0, which is undefined. We can therefore apply the L'Hopital's rule. Remember, L'Hopital's rule can be applied if and only if direct substitution gives you 0 over 0. And what is L'Hopital's rule? We simply differentiate the top and we differentiate the bottom separately, like we did in question number 3. Look at question number 2. In this case, direct substitution will give you 0 over 0. 2 squared, 4. 4 minus 4, 0. 2 minus 2, 0. In this case, direct substitution also gave 0. So we applied L'Hopital's rule. In this case, direct substitution is also giving us 0 over 0, undefined. Let's apply L'Hopital's rule. To do that, we differentiate the top separately and we differentiate the bottom separately. So let's differentiate s cos s minus sin s. How do we do this? Given s cos s, this is not something you just differentiate easily. No. This is a product. Look at it. This is the same thing as s times cos s. To differentiate products, you apply the product rule. What does product rule mean? Product rule means if you are given two values, let's say u times v. If you are given u times v, which is the same thing as uv, it says you keep u constant, you differentiate v, plus you keep v constant, you differentiate u. Mathematically, it means if you are given two products, let's say uv, or you are given y equals function of s, dy over ds is equals u dv over ds plus v du over ds. It means you keep u constant, differentiate v with respect to s or with respect to any function given, v constant, differentiate u. In this case, we have s cos s, s times cos s. So let's call this u and let's call this v. If that is understood, the y ds will simply be equals u is s, so keep s. Dv ds means differentiate v, and v is cos s. What is the when you differentiate cos s, what do you give? This is differentiation of a trigonometric function. When you differentiate cos s, you get minus sin s. When you differentiate sin s, you get cos s. So this is simply times or dot minus times minus sin s plus, what is v? V is cos s, so we keep it constant. Dv ds, du ds means differentiate this u, which is s, and when you differentiate s, you get 1, so times 1. This is simply minus s sin s plus cos s. So this answer is just for s cos s, so s cos s is minus s sin s plus cos s, minus here still here. How about when we differentiate sin s? We get cos s, so this is cos s. Then when you differentiate s raised to the power of 3, this is, you use 3 to multiply here and subtract 1 from the power to give you 3 times s raised to the power of 3 minus 1. 3 times s is 3s, and 3 minus 1 is 2. So when you differentiate s raised to the power of 3, this is what you get. So we've gotten the numerator, denominator. Now let's write that down. So this becomes the limit of minus s sin s plus cos s minus cos s over 3 s squared. So this is the same thing as plus cos s minus cos s. This will give you 0. So we have minus s sin s all over 3s squared. From here, as s tends to 0, what will happen? 0 raised to the power of 2 is 0. 3 times 0 is 0. Sin 0 is 0. 0 times 0 is 0. So this has given us 0 over 0, which is also undefined. What do? We continue L'Hopital's rule again, because we can't have undefined as our answer. Not possible. So what do? We differentiate the top separately and the bottom. So this will give you the limit s tends to 0 over, differentiating the bottom is simply this times here, then remove 1 from the power. Okay, that is algebraic differentiation. So 3 times 2 is 6s, 2 minus 1 is 1, 6s raised to the power of 1, or simply 6s. How about differentiating minus s and s? This is another product rule. Do you know why I brought out this question? Yes, this is like one of the hardest questions you will get. Yeah, one of the hardest under trigonometric functions in limit. So I felt if I'm able to explain this well, and you actually understand this very well, there is no question you'll be given in limit that you won't be able to solve. No question. So it may seem long or something, but it's actually step-by-step process, and it should be very easy for you to understand. So follow it, then open your own rough notes and solve everything like 3, 4, 5 times. That is how you study. If you're able to solve it first time with little mistake, second time with little mistake, before 3, 4, 5, 6, 7 times, you'll be able to solve without any mistake. That's how to study. So we apply the rule here again. And I told you s sine s is a product, which is minus s times sine s. And remember the rule. We keep this constant, minus s. Then differentiate this. When you differentiate sine s, you get cos s. So cos s plus you differentiate this. When you differentiate minus s, you get minus 1. Minus 1. Then you keep this constant, sine s. So you can come in any order. You can keep it constant first, then differentiate minus s to have minus 1. So this will give you minus s cos s minus sine s. Since sine s times minus 1 is minus sine s. So let's put this here to have s minus s cos s minus sine s So now we are here. By direct substitution, this will give you 0 times 1, 0. This is 0. 6 times 0, 0. So you still have 0 over 0 undefined. So we need to apply L'Hopital's rule for the third time now. And do you know why people don't like maths or people don't get good at mathematics? Saying this, the first thing that comes to your mind is, oh, again. It's not a big deal, it's not a problem. You are doing the same step over and over again. You should be happy. Be doing your thing. Life is not always simple. Don't always expect things that are simple. But this is even simple this time around. The same procedure. You continue doing it. You get your answer. Okay? So, L'Hopital's rule, we have this long one. So, differentiating sine s, we obviously get cos s. So, this will give you cos s. Then, limit as s tends to 0. When you differentiate 6s, you get 6. Okay? This is the same thing as raised to the power of 1. Remember, in differentiation, we say the power times here. So that is 1 times 6 to give you 6. Then you subtract 1 from the power. So 1 minus 1. This will give you s raised to the power of 0. And remember, in mathematics, any reasonable thing raised to the power of 0 will give you 1. So this becomes 1. And 6 times 1 is 6. That is why differentiating 6s, you get 6. Now differentiating s cos minus s cos s and using product rule. Keep minus s constant times, when you differentiate cos s, you get minus sine s plus, keep cos s constant, cos s, times you differentiate minus s to give you minus 1. So this becomes minus times minus is plus s sine s cos s times minus 1. That is obviously minus cos s minus cos s. So we simply have s sine s minus cos s. Okay, so this is limit as s tends to 0. s sine s minus cos s minus cos s is minus 2 cos s over 6. Now let's substitute. If s is 0, as s tends to 0, we have 0 sine 0 minus 2 cos 0 over 6. This is sine 0 is 0. 0 times 0. So this is 0 minus cos 0 is 1. 2 times 1 is 2 over 6. So this will give you minus 2 over 6 and minus 1 over 3. So take a look at it. That is it for today on limits of a function. And I hope you find this very, very helpful. Feel free to check out my other calculus videos, other mathematics videos, physics, marketing, commerce, chemistry, and many other amazing videos.